Okay, what if I told you there's a skyscraper out there that cools itself in a scorching hot climate without any air conditioning? I know, it sounds like something from the future, but it's very real. And the incredible inspiration behind it, well, it came from some of the smallest, but maybe the most brilliant engineers on the entire planet. So, let's get into this amazing story of biomimicry.
Right. Take a look at this building. This is the Eastgate Center in Harare, Zimbabwe. It's a massive place, but the most incredible thing about it is actually what it's missing. You see, in a city where temperatures can really soar, this building uses just a tiny fraction of the energy of a similar-sized building. Why? Because it has no traditional AC. So the question is, how in the world does it stay cool? Well, the answer lies with termites. So how does this thing actually work? Well, to get to the truth, we first have to explore the popular story that you've probably heard, the idea of a building that literally breathes. Think about it this way. On one side, you've got your standard modern office tower. It's basically a sealed glass box that relies on these huge, brute-forced HVAC systems. I mean, they can eat up to 20% of the entire construction cost, never mind the insane energy bills. But on the other side, you've got Eastgate. It uses this radically different passive approach inspired by nature to get the exact same result with way, way less energy.
Now, there's a name for this approach. It's called biomimicry. It's a really simple but powerful idea. You just look to the 3.8 billion years of research and development that nature has already done to solve our complex human problems. The architect of Eastgate, a guy named Mick Pierce, did exactly that. He looked at the local termite mounds and just asked, "Hey, what can you guys teach us?"
So to really understand the lesson here, we have to understand the teacher. Let's take a closer look at these amazing, ancient architects, the termites.
And to really appreciate their skill, you gotta understand their history. Get this, scientists in South Africa recently discovered active termite mounds that are an astonishing 34,000 years old. I mean, just think about that. These structures have been continuously lived in since the time of woolly mammoths. That is not just architecture, that's a living legacy. And you know what? They don't just build to last. They build at a scale that is just mind-boggling. In one region of Brazil, there's a sprawling city of an estimated 200 million mounds. It's spread across an area the size of Great Britain. Think about that for a second. An insect civilization whose real estate is as vast as a country.
And to put all that hard work into perspective, the amount of soil they dug up to build those mounds is equivalent to about 4,000 Great Pyramids of Giza. This isn't just some quirky fact. It's the single greatest known example of ecosystem engineering by one species. These are not just bugs, these are absolute master builders.
But here's where the story takes a really fascinating turn. The popular explanation for how these mounds work, well, it might not be the whole truth. Let's uncover the mound's real secret.
It's the million-dollar question, right? How do these millions of tiny termites, buried deep inside these huge earthen structures, manage to breathe and keep a stable temperature so they can farm the fungi they need to eat?
Okay, so the story you've probably heard goes something like this. The mound acts like a giant lung. The popular theory is that hot air from the colony rises up a central chimney and then cool air sinks down the sides in this constant loop. Another idea is that wind blows over the top and pulls air through the structure. It's a really elegant, appealing explanation. But is it right? Well, here's the plot twist. A scientific review that looked really closely at the very mounds that inspired Eastgate found, and I'm quoting here, there is no scientific evidence that termites regulate the nest temperatures. This pretty much challenges the entire foundation of that popular story.
So what's really going on? Well, the research shows that the nest temperature isn't constant at all. It actually varies a lot between winter and summer. The mound isn't acting like an AC unit. Instead, it's acting more like a giant thermal battery. It's the sheer mass of the mound and its connection to the deep, stable temperature of the soil below that protects the nest from extreme daily temperature swings. The ventilation we see is more about gas exchange, getting CO2 out and oxygen in, and it's powered by the daily solar cycle. So, if the original story isn't quite right, how does the Eastgate Center really work? This brings us to a super important distinction. The
the difference between inspiration and just direct imitation.
Eastgate's system is absolutely ingenious. So at night, when the outside air is cool, it's drawn into the building at the lower levels. It then flows through these hollow spaces inside the thick concrete floor slabs, cooling them all down for the day ahead.
Then, during the day, that cool concrete absorbs heat from people, from lights, from computers, and that keeps the office spaces comfortable. The warm, stale air naturally rises up through a central atrium and is vented out through chimneys on the roof. That's called the stack effect. But, and this is the key difference from the termite mound, the system isn't purely passive. It gets a crucial boost from fans. Low-volume fans during the day, and then high-capacity fans at night to really supercharge that cooling cycle.
So let's just lay it all out. The termite mound is a truly passive system. It's stabilized by the thermal mass of the Earth and driven by daily solar cycles. No moving parts. In contrast, the Eastgate Center is a hybrid system. It's inspired by the principles of the mound, that's the thermal mass and passive ventilation, but it uses active mechanical fans to make the whole process more efficient and reliable for a building full of people.
Okay, so what does this all mean? The fact that the original story was, a bit of an oversimplification doesn't make the achievement any less remarkable. Actually, I think it reveals a deeper, more powerful lesson.
These are the real takeaways from the termites. It's not about building a giant human-sized mound. It's about getting the physics right. First, harness the daily temperature swings. Second, use a building's thermal mass like a climate control device. Third, design for passive ventilation like the stack effect. And maybe most importantly, this whole story shows that the best biomimicry is about deeply understanding nature's principles, not just superficially copying its shapes.
And when we look back at these incredible termite cities, we can see they are so much more than just a clever trick. They are a profound example of sustainable, resilient design, perfected over tens of thousands of years.
So when you really see what's possible, it raises a powerful question. For millennia, nature has been developing these brilliant, energy-efficient solutions right under our noses. The real question is, what else can we learn from it all? And what are we waiting for?